Welcome everyone. My name is Hallengren. I'm going to talk about the SQL Server Maintenance Solution and how you can get the most out of it. Please take advantage of everything that PAS has to offer. And don't forget the session evaluations. Here is some information about me. I work as a database architect in an investment bank in Denmark. Here is my contact information. Please feel free to send me emails after the presentation. I'm a Microsoft MVP data platforms since some years back. Here is the agenda for today. I know that some of you are using the scripts already. So in this session, we're going to look at some of the little bit more advanced scenarios and features. We're going to look at how you can use the script to improve backup performance. We're going to look at striping to a dynamic number of files. We're going to look at some aspects of TDE and compression, and also smart transaction log backups. We're going to look at how you can do backup to Azure Blob storage, and also how you can do backup of databases in parallel. We're going to go through availability groups, SQL Server on Linux, and also managed instance. And finally, we're going to look at one new feature for statistics. I'm going to do a quick intro here for those of you that's not been using the scripts. So it's a store procedure-based solution for backup, integrity check, index, and statistics maintenance. It can be used in all versions of SQL Server since 2008. It is totally free and open source. And you can find the scripts and documentation on my website here. Okay, now let's look at how you can improve backup performance. So there's a few different ways. So one option is to use the option BUFFERCOUNT and MAXTRANSFERSIZE. And that is probably the easiest option. You just specify these two parameters here. The values here I've got from a blog post from the SQL Cat team. And we've been using them in our environment for a long time, and it's been working well. But of course, you need to tweak it to your environment. So if you're using those two parameters here, then you will see greatly improved backup performance, but you will also see increased CPU utilizations on the server. Another option is to increase the number of backup files. So you can do backup to 2 files or 4 files or even larger number of files, also called striping. And this is very useful for large databases. For smaller databases and medium-sized databases, it doesn't really make sense. So the question is then, how do you configure it if you want to have multiple files to your large databases and smaller number of files, so just one file for your smaller databases? So what you can do then is that you can dynamically calculate the number of backup files, and I've added 2 parameters for that, or 2 features for that. So one option is that you specify a threshold for when multiple files should be used. So in this case here, I set it to 1 terabyte and 4 number of files. That means that databases that are 1 terabyte and larger will get 4 files. Databases that are smaller will just get 1 file. So it is like an easy way to configure it. You will get striping for your large databases, and you will just get a single file for your smaller databases. Another option is that you can specify a target size for the backup files. So we have this parameter here, and here I also set it to 1 terabyte. So what this means is that the script will dynamically calculate the number of files, just max 64, because that's limitation in SQL Server. So for example, in this case here, if you have a database that is 4 terabyte and you set this to 1 terabyte, then you will get 4 files. If the database was 8 terabyte, then you will get 8 files. So this can be very useful in case we have some kind of limitation for how large the file can be. And that is, for example, if you do backup to Azure Blob storage. So let's see how that looks like. So I prepared a demo here. So let's see here. So I have 2 databases here in a demo, one very small DB and one very large DB. So we're going to back up those 2 databases, and we specify that we want 4 files, and we set the threshold here to 10 gigabyte. So let's see how that works. So we can see the output here. So the first database, very small DB, is backed up to just 1 file. And then we have the very large DB. So that is 11 gigabyte. That is just above the threshold. We set the threshold to 10 gigabyte here. Database is 11 gigabyte. And now let's see at the backup command. So that is backed up to 4 files. So that seems to work. So this is an easy way to configure it. If you have some large databases, some small databases, then you just can add those parameters. You will get multiple files for your large databases, better performance. And for your smaller databases, you would get your single files. So now we're going to look at TDE and backup compression. So let's say that you have a database with TDE, transparent data encryption. So before SQL Server 2016, if you try to compress that backup, then it would not compress. The backup would just take longer time. In SQL Server 2016, Microsoft added support for compression, but you have to specify max transfer size greater than this value. Otherwise, it will not compress. So to make it a little bit easier to use in database backup, if the database has TDE encryption, then I'm automatically adding max transfer size and this value. And that means that you will get compression also for those databases with TDE. And you don't have to think about adding this option. It will be taken care of automatically for you. So let's see how that works. So I prepared a demo here. So we have a database here, encrypted DB, that has TDE, and we're just going to do a compressed backup. So see how that looks like. So I started a backup here, and let's look at the output. So we can see here that the encrypted DB, we can see here that it's encrypted, meaning TDE. And then now let's look at the backup command. So we can see here that compression and a max transfer size. So if you look again at the parameter, we see that we specify compression. That's why we got this one. But we did not specify this one here. So that got added automatically for the database that was encrypted. So this is just a way to make it a bit easier to handle databases with TDE encryption. So next we're going to look at smart transaction log backup. The idea here is that you want to do more frequent log backups when the volume of transaction is high. So when there's a lot of activity on the server. And Microsoft has added 2 columns that is useful here. One is where you can check the amount of log that's been generated since the last log backup. Another one is where you can see when the last log backup was taken. So I'm using these new columns in database backup, and I added 2 parameters. So one of the parameters, you specify a size in megabytes. So whenever this amount of transaction log has been generated since the last log backup, then there will be a new log backup. The other one is the number of seconds since the last log backup. So what does this mean? It means that when there is a lot of activity, then this threshold here will be reached and there will be a new log backup. In periods with low activity, then you still want log backups at some intervals. So then when it's been this number of seconds since the last log backup, then a log backup will be performed. For this to work, you will need to run the log backup at a frequent interval. So what will happen then? So let's say that you have many different databases. That means that for each execution of database backup, some of your databases will be backed up and some of them will be skipped. The ones with the most activity will be backed up more frequently. So let's see how it works. So I have a demo here, this database here, wide wall importers, data warehouse, and I'm going to do log backups. I specified 100 megabyte as the threshold and 300 seconds. So let's try executing it and see what happens. So then we can see here that the last log backup here was some hours ago. There's not been a lot of transaction log records generated. And we got the log backup. And that is of course because it was a few hours since the last log backup. That's more than 300 seconds. Now let's try executing it again. What happens? Now we see it just skipped. And that is because the last log backup here, that was just a few seconds ago. And there's not been much transaction log records generated. One more time, still skipped. So now what if we generate some transaction log records? What happens then? So we do an update statement here. I think this should just take a few seconds. So the idea here is to see if we can pass this threshold here, 100 megabyte. Okay, this is completed. Now we execute the stop procedure again. And now let's see what happens. Now we can see here that there's been 127 megabyte log generated since the last log backup. So that's larger than a threshold of 100 megabytes. And we can also see that a log backup was performed. So that seems to work. Now if we run it again, what happens then? Then it's skipped again. And it will be skipped until one of those conditions here has been met, either the 100 megabyte or the 300 seconds. So this feature enables you to do more frequent log backups in periods with high activity on the servers. Now we're going to look at backup of availability groups. This is something that I get a lot of questions about, and the reason for that is there are some limitation when it comes to backups on secondary replicas. On secondary replicas, you can only do copy-only full and transaction log backups. On the primary replica, all the backup types are supported. There's one setting that's important to be aware of, and that is on the availability groups, you can specify your preferred backup replica. And by default, it's set to prefer secondary. But you can change it, for example, to primary if you prefer that. So if you're going to do backups on a secondary replica, there are some important things to be aware of, some pros and cons. So the big advantage is, of course, that you're reducing the load on the primary replica where you're running your production workload. Drawbacks is that if the secondary replica is behind in a synchronizing state, then the backup will not contain the latest changes. Another drawback is, as I mentioned, you cannot do differential backups. And this can have an impact on your time to do a point-in-time restore, depending on your backup strategy. So based on these things, what are the possible backup strategies that you can have for availability groups? So the most simple backup strategy is to do all the backups on the primary replica. Full, differential, log backups. And you set then the backup preference to primary. And this works well in most scenarios. Another backup strategy that you can have is to do your backups on the secondary replica. Then you can only do copy-only, full backups, and log backups. And then, of course, you need to specify backup preference prefer secondary. And the third possible backup strategy that you can have is to do your full and differential backups on the primary replica, but do your log backups on your secondary replica. And then you also need to specify prefer secondary for the backup preference. So let's say how it looks like in a script. So for the full backup, you just specify if you want to do a backup on the secondary replica. For the full backup, you just specify copy only equals to yes. And for the log backups, you don't need to specify anything. So let's see how that looks like in the scripts. So here we have an availability group with two replicas, primary, secondary. So let's start by looking at the settings here for the availability groups. We see the backup preference here is prefer secondary. So now let's try executing the backup store procedure, both for a log backup and for a full backup. First on the primary and then on the secondary, and see what happens. So this one here is the primary. So I execute the full backup first. So we can see here that this is in the primary role and the backup preference is secondary. And it's not the preferred backup replica. And it's skipping. No backup was performed. Now let's try with the log backups. So we see it looks the same. And again, no backup was performed. Now let's try the same on the secondary replica. So we see here, this is the secondary. So I now do the copy only full backup. And now we can see that this is the secondary replica. And we can see that that's also secondary is the backup preference. And also that is the preferred backup replica. Yes. and there was a backup that was performed. So now we can see here, copy only backup was performed, full copy only backup. So let's try the same for the log backup. We can see it looks the same here. And again, a log backup was performed. So this seemed to work as expected. Now let's go into Checkdb of availability groups. So there are some important things to be aware of. So one is that if you're Enterprise Edition, then you can do Checkdb on the primary and on the secondary replicas. If you're on Standard Edition, then you can only do Checkdb on the primary replica. Well, there is a workaround. You can create a snapshot on the secondary replica and do a Checkdb on that. But directly on the database, you can only do Checkdb on the primary. So another important thing is that if you check one replica, for example, the primary, that means that that one is in a good state. It doesn't say anything about the other replicas. So you can check the primary replica, and that shows that that's in a good state, but maybe you have corruption on one of the secondary replicas. Or the other way around, if you check the secondary replicas and they're showing that they are in a good state, then it could be that you still have corruption on the primary replica. So what does that mean? So the best is of course then that you check all your replicas, and that is also the default in the script. You can also choose to just check the primary or just check the secondary replicas. And if you, for example, check the primary replica, and if you have automatic failover, then sometimes one replica will be checked, sometimes the other replica will be checked. So let's see how it looks like. So I'm using the same availability groups as in the previous demo. So we're going to see here that first we're going to try here availability group replicas all, and we're going to run that on the primary and on the secondary. And then let's see what happens. So we can see here that this is the primary, and we can see that it's starting the Checkdb command. And for the other server, we see that it's a secondary, and it's also running the Checkdb command. So let's see if it's completed. So when this one has been completed, we should try to, instead of all, specify primary, and then see what happens. Okay, now this was the first one completed. Let's see if it's completed here also. Yes, successful. Okay, now we try running it with primary instead. So this is on the primary replica. So we can see here that primary, and it's executing the Checkdb. Now let's try the same on the secondary replica. And now we can see here that it's secondary, and it was skipped. Nothing was done. And let's see if the other one, this one is completed now also. So this is how it works with Checkdb on availability groups, and how you can use the stop procedures for that. Now we're going to look at backup of databases in parallel. So the scenario is that you have a very large number of databases, and just backing them up sequentially in a job can take a very long time. So for this scenario, I've added a new feature, and that is a parameter called database in parallel. So when using that, you can have multiple jobs working together, backing up the databases. And it's using a queue table. So let's see how it looks like. So on this SQL Server instance here, I created 100 databases, and we're going to use 2 sessions corresponding to 2 jobs to back up the databases. So I have one here. Let's create one more, and we'll start with full backups. So we have one here, session 58, and we have another one here, session 54. Now let's look at the parameters. So we have the one I mentioned, database in parallel. And we have another one called database order. So here we specify that the database should be backed up in the order of the size, starting with the largest databases. And the reason for that is that when you have multiple sessions, multiple jobs like this, you want to have an even distribution of the work between the jobs or between the sessions. And the most efficient way of doing that is to start with the largest databases. For this to work, the sessions or the jobs has to have identical parameters. And you see that we have that here. They're exactly the same. So now let's start both of those 2 jobs. So they're running now. In the meantime, we're going to look here at the queue tables. Now let's see here. So in this one here, we will have one row for each queue and database. So you see here that it started with a database called test010. And the reason for that is that that is the largest database on the server. And we can see that one of the sessions, 54, is working on that. It started, has not completed yet. We can see that the other one, session 58, that's had already been processing something like 10 databases here. And it's working on another one here. So let's try to refresh here again and see how it looks. Now we can see that session 54 completed the first database. And we can see that the 2 sessions, 54 and 58, they're working together now, processing the databases, taking like every other database. And how it works is that when a store procedure has finished one database, it's just writing, that's completed, and then it just grabs the next database, processes that, takes the next one. In that way, the sessions or the jobs are working together on databases in the queue. In this example here, we have two jobs, or 2 sessions, but we could have 4 or 6 or 8. Of course, the more jobs, the higher load on the servers, but the faster you can process the databases. So you need to keep a close eye on the CPU and performance of the disk systems, and try to find out what is the right number of jobs in your environment. So now let's look at the same thing, but for a log backup. So I just close this one here. And again, I create 2 different jobs, 2 sessions. So the only differences here are that, of course, we specify log instead of full, but also here the order. Here we are not backing up in the order of the size, but in the order of how much transaction log has been generated since the last log backup. And this is the same DMV that we're using as in the smart log backup feature that I was showing before. So that means that the databases with the highest activity, they will be backed up first here. And again, that is to get an as even distribution of the load between the two jobs as possible. So let's execute it and see how it looks. So I start both sessions. And then we're going to look at these queue tables again. And this time we're going to start by looking at this queue table here. And then we can see that we will have what's called a queue here for each combination of store procedures and sets of parameters. So we see we have one for the full backup and one for the log backup. So now let's focus on the log backup. So that's queue number 2. So now we can see here that the two jobs or the two sessions, they're processing the databases together, taking every other database. And we can see that everything has completed. And we can see here also, yes, executed successfully, and this one as well. So advantage here is that you don't need to define which databases should be taken care of by each of the jobs. You just have identical jobs, and then they're just using a queue to process the databases. So we have been, as we see here, here's the parameter again, database in parallel, yes. And then you can have different order. In this case, we used the size of the databases. In the log backup case, we used the amount of transaction log that's been generated since the last log backup. Next, we're going to look at how you can do Checkdb of databases in parallel. So the scenario here is that you have very large number of databases, and performing the Checkdb just sequentially in a job can take a long time. So this works the same way as in the previous section about backup. So we had a parameter databases in parallel, and you can use that to have multiple jobs that are working together on a queue table. So one difference here, and that is for the order. One option here is that instead of using the ordering by the size of the databases, you can do ordering by when the database was last checked. So let's see how that can be used. So we're working again on the SQL Server with 100 databases, and we're going to have 2 sessions, 2 jobs that are doing Checkdb together. So we specify database in parallel, yes, and database order, database last good check. So starting with databases that has not been checked in a long time. And we have 2 different jobs. We can see here that the jobs are, the sessions are identical. So let's start. We start in both sessions. So we have this time 54 and 58. Now let's have a look at the Q tables again. Now we can see here that we got one additional queue for the integrity checks. So let's filter on that. So now we can see that session 58 is working on the largest database, test 010. And you can see the other session 54. That is just going ahead, checking the smaller databases. So let's see here. Okay, so let's update it again. Now we can see here that 58 is finished with the first database. And now we can see that they're starting working on some of the smaller databases together with 54. So now they're taking like every other database. And they're not really finished. Let's try again. So now they've completed all the databases. So you see, it works exactly the same as in example with the backups. And again, in this example here, we had 2 sessions, two jobs, but we could have 4 or 6 or 8 or how many we wanted. And again, advantage here is that we don't need to define which databases that should be taken care of by which job. We just have multiple jobs working together on a queue table. Now we're going to look at how you can do backup to Azure Blob storage. So there's 2 ways of doing backup to Azure Blob storage. One way that was introduced in SQL Server 2012, we use something called a storage key that you put into a credential, and then you use that together with a URL in the backup command. It has some limitation. You cannot do striping. There's some other option that's not supported. So in SQL Server 2016, Microsoft came with a new way of doing it using something called a shared access signature. So what you do is that you generate the shared access signature in the Azure portal, and then you take that and create a credential, and then you just need to specify the URL when you do the backup. So this new way of doing it, using shared access signature, has some advantages. It supports larger databases, it supports striping, and it has better performance. So let's see how it works. So now we're going to take one database here, and we're going to do backup to Azure Blob storage. And here is my account, storage account. And here is something called a container. So we do a full backup, compression, and we do it to 8 files, striping to 8 files. These options here is to get better performance. So let's try it out. So now we can see here that it's starting the command here, backup database, wide rolling portals to URL. So instead of to disk, it is to URL. And then you can see the storage account here, and the container, some directories, and the file names. So let's see here, we're getting 8 files. And we can see that it completed successfully now. So we're also going to look at this credential that I was talking about. So in this case, we're using the shared access signature, and then you don't need to specify the credential. but you still have to create it in advance. So let's look at the credentials. So now we can see that there is a credential with the same name as the URL. So the storage account and the container. And identity is shared access signature. And you can read in documentation at Microsoft how to create the credential, how to do it, but it's pretty straightforward. So this worked fine. Now let's take a bit closer look here. So we see that we got storage account, container, and then we have a directory structure here with the server name, the instance name, database name, and then the file name here again, also containing server name and instance name, database name. So let's say that you don't want to have the server name and instance name in the directory and in the file name. So what can you do then? So for that I've added two new parameters. So you can specify the directory structure and the file name. So basically I've just taken the defaults and then I removed the tokens for the server name and the instance name. You see it's all tokens here like database name, backup types and so on. So I removed those for the server name and the instance name. And the same for the file name. So let's see how you can use it. So now we execute the same backup again. So let's see here. Now we have the, again, storage account, container, and the database name. So no server name, no instance name. And the same in the file name. Database name, no server name, no instance name. So this seems to work. So by using these parameters, you can basically get the directory structure and the file name exactly as you want it. And now we tried it here for backup to URL, but you can do the same with backup to disk. So next is backup on SQL Server on Linux. So in SQL Server 2017, Microsoft added support for Linux. So I have added support in my maintenance scripts. The place where I needed to do changes was in the backup. And for example, one difference is that the directory parts are different in Linux. It's / instead of backslash. Initially, there was a problem with cleanup of old backup files, as the extended store procedure that I'm using was not working on Linux. But this has been fixed in the latest CUs, both for 2017 and 2019. And I've also fixed that in my scripts. So everything related to backup should be working now in SQL Server on Linux. So let's do a quick demo here and see how it looks like. So let's do a version check first. We're on SQL Server 2019, CU8, and this is Linux Ubuntu. So I just specify the directory like this. This is the default directory. I just do a full backup, and let's try it out. We can also see here that it's, here we can see that it's Linux. We have one database here, tests. And we can see here that is doing the backup, just as normal. So one thing to that you can see here is that Normally on Windows, it will create the subdirectory first. But in SQL Server on Linux, you don't have to do that. You can just specify the new directory as a part of the backup command, and then it will be created automatically. So you don't need to create subdirectories in advance. So that's why I could skip that command. And we can see here that the cleanup is also working. Now let's talk about managed instance. So all the scripts are supported on Azure SQL Database Managed Instance. So one thing about backups. So Microsoft, in managed instance, Microsoft is responsible for doing the backups as is a managed service. You can do backup yourself, but only copy only full backups to URL. And these backups, you can't bring them back to on-premises because this is like a newer version of SQL Server. But you can use them to do backup restore between managed instances. Now let's go into statistics. So I added a new parameter for statistics in index optimize. So the idea here is that if very few rows in a table has been modified, then there's really no point in updating statistics. So I added a parameter called statistics modification level, where you can specify a percentage threshold for when statistics should be updated. So in this case, only if 20% of the rows in the table has been modified, or the sublinear threshold, this formula here, has been reached, then it should update statistics. And this formula here, this is the same threshold that is used in auto-update statistics. I've now covered all the scenarios and features that I was planning to cover. You can find the latest version of the script on my website and also on GitHub. The documentation is available on my website. If you have a bug you would like to report or an idea for a new feature, please create an issue on GitHub. Thank you for attending this session. If you have any questions after the presentation, please feel free to send me emails. I will try to respond.